Hi, everybody, and welcome to Section 3.3, Antiderivative Formulas. Again, we're going to start off by talking about the area of a certain function. So, given a function f, we define the area a of x to be some initial value plus the integral from some point to another point, here's from 0 to x, of my function. And that would equal my area, my net area. We note that a of 0 is the same as a sub 0. It just means when x is 0. A of x is increasing when f is positive, and a of x is decreasing when f is negative. You can use this function to construct a function that satisfies the derivative of the area is equal to f of x. If we start here and we take the derivative of both sides, well, the derivative of a constant is 0, so that disappears. And the derivative of an integral, we've already talked about this, is the same as, this time because it's between x and 0, it'll be f of x. Now let's look at a graph. Suppose f of t has the derivative shown below. So this is a graph of the derivative. F of 0 equals 3. And I want to find f of 5 and f of 9. I know my area is equal to f of 0 plus the integral from 0 to 5 of f of t dt. What we need is the area from the curve to the x-axis. And I need this area to find the next part, which is from 0 to 9. To find the area from 0 to 5, I can recognize that this is a triangle, and that's going to equal 1/2 base times height. And my base here is from 0 to 5. And this right here would be my height. So my base is 5, and my height is 1. So my area is 5/2. But because it's below the x-axis, it's negative. So if I wanted to know what f of 5 is, f of 5 is going to be equal to f of 0, which is 3, minus 5/2, which is 1/2. If I want to know what f of 9 is, it's going to equal 3. And again, it's going to equal that minus 5/2. And now I have to figure out the area of my last region, which is in blue. I know that it has 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So I know it's plus 9. And then I need to find this area. And to find that area again, I would find the area from 5 to 6 is again a triangle, which is equal to 1/2. And here the base is 1. And the height is 3. This is 3/2 plus 3/2. This is equal to 11. My area from 0 to 9 is 11 if I add in my initial value, and my area from 0 to 5 with my initial value is 1/2. Let a of x equal the integral from 0 to x of f of t dt. Now, we're using this f of t dt. This t is really what we call a dummy variable, which means we're just using it because we're not exactly sure where it's going, but here it's telling me it's going from 0 to x. That's why it gives me the area in terms of x. This is a picture of f of t. At what values of x does a of x have a local min or max? To find the local min or max, we need the derivative to equal 0. If I want to take the derivative of both sides, and the derivative of the integral, as we've said before, is equal to the actual function. So if I want to know where this function has minimums or maximums, it's when the derivative equals 0. And this is a graph of the derivative. So the derivative equals 0 here, here, and here. And now I just need to figure out, are they local mins or maxes? If I look at this graph, at 1, the graph is going from positive to negative. The slope is therefore going from positive to negative. And up here, at the top, I have a max. And the same thing is true right here. This is going from positive to negative. It starts with a positive slope, and then it has a negative slope, and that gives me a maximum. Now, at 3, it's going from negative to positive. That means we have a negative slope, then a positive slope. This makes a minimum. My maximum values are at x equals 1 and 5, and my minimum value is at x equals 3.